Okay guys, so now we're going to do question 11. If you just watch this video, just note that there's two questions that I've done from this 2021 November past paper. As you can see, it's in November past paper 2021. I did question 9 and question 10 strictly on Euclidean geometry. So if you haven't checked those, just look in the description below or comment section. I will have there's a link there, so please just have a look there for those two previous questions. Anyways, if you're new here and it's the first time watching my videos, please subscribe to the YouTube channel. I would really appreciate that. Anyways, let's get down to this question. Question 11. We are given chords of DE. Let me just write with the black pen: DE, EF and DF, right? And then we are given a tangent of KFC. Oh, okay, what a nice tangent. Anyway, so there is our diagram there, and we are asked to prove that the angle of DFK is equals to E. So we are asked to prove that this angle here is equals to this angle there, right? You can prove using different methods, to be quite honest, but the obvious method that we can see here is the Tan-Chord theorem, right? So you can just assume that this is one of the Tan-Chord theorems. So for us to prove that these angles are equal, you first have to construct a line from F passing through the center, going straight up, right? Because I want you to please note this. This is very important and critical, so you don't have to make a mistake. You don't have to, from this point here, which I can call let me call it Z, point Z, right here. So it's critical that from here you go to the direction of the angle that you're proving. So since we are proving E, you're going to go from here to the direction of the angle that you're proving. Because what can happen is this: they would ask you to prove this side. So meaning you this side is equal to this side, right? So meaning you have to go from this top to the direction of the angle that you're proving. Right? Please note that. This is just to avoid anyone making any mistakes. So once we've done that, what we need to note is this: is that our FZ, which is this point from F to Z, is a diameter, right? That's one thing that you need to note, and that ZEF is equals to 90 degrees, right? So this angle here is 90 degrees. And another thing that we need to note is that KFZ, or you can say O, it's up to you, that angle of KFZ is equals to 90 degrees, right? So this angle here is also 90 degrees. So here you can simply write angle on semicircle, right? And then here you can write tan perpendicular to radius, right? So now that you've proven this, let's just label our E. This is going to be E1, this is going to be E2, and this is going to be F1, this is going to be F2, right? So another thing that you need to note is this. Let me just try and use the highlighter, different color for us to see. So what I need you to note is this. Remember this theorem here, angle on same segment, where this angle is equal to this, and this angle is equal to that. Something like that applies here. I'm just going to highlight it with green. So it's from here to here, and here, and here. So you can see angle on the same segment. So what it means is this angle here, which is E1, right? E1 is equals to this angle here, which is F1, right? So these two angles are equal. So you can say E1 is equals to F1. Reason, angles on same segment. I know maybe your teachers will tell you no longer use this definition, use a certain definition. Please use that definition. But if you've written this, you won't be given wrong. Yes, so now we've proven that. So if these two are equal, right, but E1 and E1 plus E2 is equals to 90 degrees, right, which is this one here, and F1 plus F2 is equals to 90 degrees. Right? So if because there's a commonality, if there's a term like that, they're common, right? There's something common here, is that E1 plus E2 gives you 90, F1 plus F2 gives you 90, right? And we just said E1 is equals to F1, right? Not F1, sorry, let me correct myself, I didn't see properly. It's actually F2. As you can see here, it's written 2. So it's F2. E1 is equals to F2. Let me write F2 here. So if we've proven that E1 is equals to F2, and we are saying that the combination of these two gives you 90, and the combination of these gives you 90, so it also confirms that E2 and E2 is equals to F1, right? Therefore, you can just conclude by that angle E2 is equals to F1, and this is the critical part now, right? Because we've concluded from this statement here and these two statements that I've just wrote here, you can see now that this is what we are actually looking for. F1, which is this one here, right? And E2, which is this one here. So once you've written this, therefore you can conclude and say KFD, right, is equals to E, angle E, right? So you can conclude that because this applies here. So you're basically done with this theorem here. But you need to write the reason because it will help the marker to tell which theorem did you actually use. Yes, they'll see by your steps, but you need to just conclude with the theorem that you use. So you can say tan chord theorem. Then yeah, we're done with this problem here, and you're gonna get all your marks. So now we're going to question 12. Sorry, question 11.2, right? So in 11.2, we are given PK as the tangent to K, given chords of LS, and we are also told that MN is parallel to SK, right? And we're given all these chords, right? So make sure you underline all the critical points, and yeah. So as you can see, the diagram here, it looks really nice, right? So let's solve the first question. First part of the question says that we must prove with reasons that A, K4 is equals to NML. So this is K4, right? So this is K4 is equals to NML. So we are told that it's equals to this angle here. So sorry for not writing a straight line. So it's equals to this angle here, right? K4 is equals to that angle. How can we prove that? We are told that these lines are parallel. Just so you know, this is parallel to this one here. And if you see clearly, I'm just going to use a highlighter this time around. If you see clearly from here, this triangle here, And remember that we were told that this is actually a tangent. This orange line is a tangent. So this orange line together, so it's going to do what? It's going to produce an angle of K4, right? With this tangent of KL, which is this one here, KN, right? So the KL will subtend an angle here. So this is S, by the way. So it will subtend this angle. So basically, angle K4 is equals to angle S1, right? So reason for that is tan chord theorem, right? So once you've proven that, then now I want you to note this. So let me first remove this highlighter because now we've proven that. I want you to note this. Let me use a different color. Let me use blue. So I want you to note this this part here, this one here, and this one here, right? So this looks like F, right? And remember, since these are parallel, oops, what did I do? Since these are parallel to each other, so you're having F like this, right? And this is parallel to this. It means now that this angle here is equal to this angle here by corresponding angles equal, right? So we can simply say now that this angle here of S1 is equals to this angle here of M, or you can say NML, right? So you can say angle S1 is equals to angle M, right? Which angle M is basically NML, right? So therefore, if S1 is equals to this angle here, but S1 is equals to K4, therefore it concludes that K4 is equals to NML, right? And the reason for that you can say corresponding angles equal, right? By indicating that NM is parallel to ST, right? So yeah, we are done with this part of the question. Let's just remove. If there's anything that I omitted, please let me know in the comment section. That would really help, but we are done with this portion. So let me just erase. So it's very critical that you come up with your colored pens if you've been practicing using colored pens to solve these problems. By the way, come with your colored pens in the exam room and just color. Color everything. I know you won't be able to erase it, but just color so that you'll be able to visualize and see right through the diagram. Sorry with the noise. Anyways, let's continue. So we're going to do B now. So B says that we must prove, remember, with reasons that this is actually a cyclic quad. So let me just, it's KLMN, KLMN, so it's KLMN, right? So we must prove that this is a cyclic quad. What you need to note is, in the previous question, we just proved that K4 is equals to M, right? And if you see clearly, this is an exterior angle. K4 is actually an exterior angle. It's equals to the opposite interior angle, right? So, basically, KLMN is a cyclic quad, right? What you're going to do is, firstly, maybe you can just write K4 is equals to MLM, right? And then you can conclude by that. But you need to indicate the reason. You can say exterior angle of a cyclic quad, right? Then you'll get your mark, because this is 1 mark. Probably you just get 1 mark for the reason and nothing else, right? So that is that with this part of the question. Erase here. So now let's go down to 11.2.2. Give with reasons that LKN is similar to KSM. So I was supposed to say triangle LKN is similar to triangle KSM. Let me just highlight these triangles. So we have triangle LKN, this one here, and then we have another one which I'm going to indicate with the orange. It is KSM. So it's K and then SM, like that. So you're proving the similarity of these two triangles, right? And what I need you to note is this, is that angle N3 is equals to angle M3, right? So the angle N3, this one here, is equals to this one here, right? Reason for this is angles on the same segment, right? If you take a look, let me just use another highlighter for you to see. Why am I saying angles on the same segment? If you take a look at, let me do this, let me see, how can I show you? If you take a look from here, right, it goes up like this and then it comes back like that, right? Then it goes up like this, right? But if you take a look, it goes straight up like that and then like that, right? But what I want you to note is this bottom part of the triangle, right? Because just from here, this portion here and this portion here, that they somehow form something that looks like this, right? Yes, somehow form something that looks like this, hence making these two angles equal. So you're just going to write angles on same segment for this one. Let me just erase this green color and leave the other color. Oops. Okay, I'm just gonna restore the color that I just removed. So this one here, cool. So now another thing that you need to note is, so you've proven this angle here, right? Remember, this is proving similarity. So, and then angle L1 is equals to angle M2. This angle L1 is equals to the M2, right? M2 is this portion here, right? It's equals to this portion here, and reason for that is so it's equals to this portion, but what you need to note is this, this portion of M2 is equals to K2, this one here, right? So what's critical first is that K2 is equals to, what's critical is angle K2 is equals to angle M2, right? Reason for that, if you take a look, we're having something like this, parallel, parallel, and then there's a line going like that, and then the 2 is here, and then the 2 is here. Oops, I made a mistake. So it's something like this, it's that, and then the 2 is here. So this is the Z, right? This is Z, right? Whereby this angle here is equals to this angle there, right? Because of these parallel lines here, right? I hope it's visible enough for you to see what I'm trying to show you. So hence K2 is equals to M2, right? Of which M2 is equals to L1, right? So now K2, so it's going to be equals to K2, so this is also equals to that, right? Because these two are equal, right? So you can include the reason here is in alternate angles equal, right? And then another part, because we've proven two angles now, we've proven angle N3 equals to M3, L2, L1 is equals to M2, which is equals to K2, right? And then now another angle that we can prove is that NKL is equals to MSK. So what is that? Let's see from the diagram. So we're saying N, let me use another color, so it's NK, NKL, so meaning we're talking of this angle, right? And then we have MSK, so it's MSK, right? So we're talking of this angle here. So and then here we're talking of this angle here, right? So these two angles, which I can denote as maybe this one I can denote as combination of K1 and K2 and K3, right? And then here it's just S2, right? So these two angles are equal. Why am I saying that? It's the third angle of both these triangles. We've already proven this N3 with this M3. We've already proven this L1 with this angle K2 here, right? So this is just the third angle of the triangle. So you can just write that angle of a triangle, right? Or you can just write sum of angles of a triangle, right? So now that we've proven all three angles, we've proven, let me just rewrite them but without reasons. So we've proven that angle N3 equals to angle M3, angle L1 equals to angle K2, angle K what? No, NKL is equals to MSK. So therefore you can now conclude by saying that these two triangles are actually they are similar. So it's going to be LKN similar to triangle. So this is triangle LKN similar to triangle KSM. Reason for this, you can say angle, 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 right? So that is that with this question. If you didn't understand, please make sure you ask me in the comments section. I will briefly explain myself. So now let's continue with another question from this problem here. So now we go to this one here, 11.2.3. We are given that LK is equals to 12 units. We are given that 3KN is equals to 4 SM. We are asked to find KS, right? So let's go back to the diagram, which will really help us to make sense to what we are given. So we are given that LK is equals to 12 units. We are given that 3KN is equals to 4 SM, and we are asked to find KS, right? So I want you to note from what we were doing in the previous question, we're proving the similarities between the triangle LKN similar to triangle KSM, right? And there's something common here. There's LK here, there's LK here. There's Kn here, there's Kn here, there's Ks, and there's Ks, right? So which means we need to just identify Sm, right? Because of every other angle besides Sm. So for us to be able to do that, we need to note that the question says that Sm 3 Kn is equals to 4 Sm, right? And so what we can do is this, because we've proven the similarities. Let's write the fractions in terms of these similarities. Let's say this Lk is divided by this Ks. So Lk over Ks is equals to this Kn, which is equals to Kn over Sm, right? So Lk we have as 12 units, so it's 12 divided by Ks, which is what we are looking for, is equals to Kn. Kn we are given as 4Sm, so you can write 4Sm divided by Sm. So these will cancel out, Sm goes away, and then you have 12 over Ks is equals to 4, right? And then from here, what you can do is you can simply remember as something that missing, right? There's something that I missed. I can tell that's something that I missed when solving this question. Please pardon me for that. So we said Lk, right, divided by Ks, right, is equals to Kn divided by Sm. And then, but we are told that this 3 Kn is equals to 4 Sm, right? So you divide by 3 both sides. Kn is equals to 4 over 3 rather. So it's 4 over 3 Sm, right? So if I write here, it would be Lk, which is 12, divided by Ks, which is what we're looking for, equals to Kn, which is equals to 4 over 3 Sm divided by Sm, right? So Sm and Sm will divide out. Will remain 12 over Ks is equals to 4 over 3, right? So cross multiply, so we have 12 times 3 is equals to 4 times Ks, divide by 4, divide by 4, both sides. Ks is actually equals to 9 units, right? Because you're going to find the product here and divide by 4. So we found Ks, which is what the question wanted. So I hope everything is making sense now. Starting to understand this topic. So now we're going to do 11.2.4, where we are told that it is further given that NL is equals to 16 units, LS is equals to 13 units, Kn is equals to 8 units. Dealing with reasons, we must determine the length of LT, right? So let me just write the info next to this diagram because it will help us. You must note that NL is equals to 16 units, LS is equals to 13 units, Kn is equals to 8, LT is what we are looking for, right? Let me just confirm, yes, LT is what we are looking for. So let's go, but before we go to the other part of the question, I want you to note this. I want you to note this in this question as you are solving, because we are looking for LT, which is this one here, from here to here, right? But I'm going to extend it because there's other parts of this that we have, right? So there is a triangle that we are going to focus on, right? From this point here all the way up to this point, it's LT, which is what we are looking for. And then what we have is that NL is equals to 16 units. So from here, let me use another color. From here, N to L, let me do this, is 16 units, right? But we don't know this one here. And then from here, L to S, we are given as 13, right? We are given as 13, and we don't know L to M, right? We don't know L to M, right? So, but we know SM, right? How do you know SM? Remember, we were told in the previous question that 4SM is equals to 3KN, right? And we found, okay, we are given KN as 8, right? So it's 4SM is equals to 3 into 8, divide by 4, divide by 4. So SM is equals to 6 units, right? So SM is equals to 6 units, so meaning that from here to here, it's 6 units, alright? So now, let us solve this problem using what we have, because we're having ln from the diagram, just by looking at the diagram. Ln from here to here, we're having ls, we're having sm, right? We just need lt, so let me just remove this and just show you what I'm talking about here. So if you just look at the triangle in this sense, and then this is parallel to this, and then here it's L, here it's N, here it's M, right? And then here it's T, and then here it's S. So what we have is this from here to here, we have 6 units, and then from here to there, right, you have 16 units. And then from here to here is what we are looking for. And then from this side to this side, I have 13 units, right? And then from here to here, I have 6. Right? Cool. So I have all the information. So what I can do is this, just so that presenting my proportionality, I can say, because I'm looking for LT, I'll say LT divided by LN, right, is equals to LS divided by LM. Then you're going to write your reason of proportionality and say line parallel to one side of a triangle. Remember that this is parallel to this, hence whatever that I just did applies. So LT is what we are looking for, divided by LN, which is what we have as 16, being equals to LS is 13 all over LM, right? LM, of which LM is just from this point all the way down. So you're just gonna add the 13 plus the 6, right? Which should give you 19, right? Should give you 19, so it's over 19. So now we can cross multiply to find our LT, which is going to be LT times 19 is equals to 16 times 13, right? And then you divide by 19 both sides. We have LT is equals to 16 times 3 or 13, sorry, 13 over 19. So our LT is supposed to give you something like 10.947 units. So this is our final answer for this problem here, which is LT being equals to 10.947 units. Yes, and now we're done with this question here. I hope you really understood and was able to go through with me and with these questions here. If you haven't subscribed, please subscribe to the channel. I would really appreciate that. And all the best with your exams, your paper 2. By the way, make sure you nail it, and you are more than welcome to give me feedback on how it went. If you feel like it, you can either send me an email on qinisodlamini@gmail.com, or you can simply send me a message on Instagram at Qiniso20. So Qiniso is spelled with Ciniso. Right, I'll just put everything in my description below. Anyways, thank you so much for watching. Please subscribe and comment down below.